Now we would like to understand about the solution. Okay, there is two types of solutions. The first one we call it as a general solutions, and another one we have the particular solution. All right. Okay, so the general solution is a solution that still having a constant, the unknown constant. For example, if you find the solution, you will get x squared and then you will have plus c over here. So we call it this one as a unknown constant. However, if you apply some conditions, and then you will have, for example, your c is equal to 3. So this one we call it as a particular solution. Okay class, let's say if you have one question, you have dy dx equal to 2x. So the question asks you to find the solution for this differential equation. As I said previously, if the question asks you to find the solution, what you need to do is you need to find what is the equation that represent the dependent variable. So you need to find what is the y-axis. These times you need to have the knowledge how to integrate. Why? Because of when you remove or you move the dx to the right hand side, so you will have this expression, and then when you are taking the integration both sides, so you will have this one, and then you solve this one, you will get this one plus c, and then you will have this one 2 as a constant, and then you integrate that, so you will have x squared over 2, and then you have another constant over here. So you simplify over here, and then you bring this one to the right hand side, so you will have x squared, let's say you will have a, which is your a equal to c2 minus c1. So this one we call it as a general solution. Okay, however, if you are given one condition, for example y equal to 3 at x equal to 0, means that you need to substitute. For example, this one you will have at y equal to 3 and then x equal to 0. So you need to substitute y equal to 3, and then you will have over here 0 squared plus a, and then your a is equal to 3. So the final answer you are substitute back, you will get x squared plus 3. So this one, since there is no element of unknown constant, it's completely solved, so we call it as a particular solution for this. And then this one we call it as a general solution. Okay, all right, I hope you understand. Okay, so now let's proceed to another types of the problem that you may counter after this. The first one we call it as a initial value problems, or it sometimes it's noted as a IVP. And then another one we have the boundary value problems, or we call it as a BVP. Okay, so how to recognize the initial value problems or boundary value problems? You need to look at their subsidiary conditions. For example, if you have one differential equation, and then it's given to you the conditions equal to 1 over here. Since here is 0, so we call it as a initial value problems. Okay, and then let's say if you have in a second order here, let's say for sine 3x, And then if you are given two conditions and then another one over here, so by looking at this one, there is no change for the condition over here, so we call it as also as a initial value problems. Okay, however, if you are given, for example, y double prime plus 7y equal to 0 with a condition y equal to 10 at x equal to 0 and y equal to 30 at x equal to 5. Look at here is a difference, so we call it as a boundary value problems, right? So I hope you understand. Okay class, now let's go to example 1.16. Okay, so if the question asks you to show that the solution given to you is the initial value problems, so it's similar with the previous one. However, for this one you need to test for its boundary condition given to you. For example, if you are given y double prime plus y equal to 0, and then you are given y 0 equal to -1, and you are given y prime 0 equal to 1. So the question asks you to show that the yx here, which is sine x minus cos x, is a solution for the above differential equation. So you need to test. So in similar way by previous example, what you need to do is you need to check whether the right hand side is equal to the left hand side, and then you also need to check this condition and also this condition. So you have 3 tasks to do. The first one, you need to test for here, and then I put 2 over here and 3 over here. So the first one, which is you need to check whether the y double prime plus y is equal to 0 or not. Okay, and then you need to find y prime first. So what you will get here, you need to differentiate this term and this term. So you differentiate sine, you will get cos x, and then you differentiate cos, you will get negative sine x. So negative with negative is positive. And then you need to differentiate once again to get y double prime, which is you will get negative sine x, and then you will got here is cos x. So you substitute over here, then you check whether the left hand side is equal to the right hand side or not. Okay, let's substitute one by one. Plus cos x, and then you have y over here. So what is your y? Your y is sine x minus cos x. It's either 0 or not. So this one will cancel off, this one is cancelled off. So your left hand side here is equal to the right hand side, so that your condition for this one is correct. However, you cannot make it a conclusion yet, since you need to check the second and third condition. Okay, so the second condition state that you need to substitute y equal to -1 and x equal to 0. Okay, so when you check here, so you need to substitute at y -1 and x equal to 0 over here. So you will have -1 over here, and then you will have sine and substitute x as 0, and then we have a minus cos and substitute x equal to 0. So you press the calculator, or you may already know this one is equal to 0 and this one equal to 1, so -1 over here, and then you will see that the left hand side here is equal to the right hand side. So now your second condition is correct. Okay, now let's do it for the third one. The third one said that if you have y prime equal to 1 at x equal to 0, so you need to substitute over here. Whether it's correct or not, y prime is equal to 1, and then we have a function negative sign, x is 0 now, and then we have a plus. Okay, we have over here y prime is cos. Okay, we turn back over here, we have y prime is equal to cos, and then your x is equal to 0, and then we have a plus sign 0 over here. So you will check this one is equal to 0 and this one is equal to 1. So your 1 is equal to 1, your left hand side here is equal to the right hand side. So means that your condition for the third one is also correct. So you can make it a conclusion. So what is the conclusion? You can make it y x, which is equal to sin x minus cos x, is a solution for differential equation given to you y double prime plus y equal to 0 at y equal to 1 at y equal to -1 at x equal to 0, and another one y prime equal to 1 at x equal to 0. So is a solution. This is the answer that the question asks you to find. Okay, I hope you understand and enjoy the session, and you may try to simplify a few more questions in the module. Thank you.